Hi everyone, I am Shubham Garg and welcome back to the lecture series of blockchain. So in today's lecture we are going to have a look at the final concept of the blockchain, that is proof of work and mining. Alright, so far we have seen introduction to blockchain, decentralization and asymmetric cryptography, and we have also have a look at SHA-256 and Merkle root tree. We have seen the demos for SHA-256 and blockchain process, that is sending and receiving ethers. We have seen using Ganache and Metamask. So this is the proof of work. We will see how a new block is added into a blockchain and it is validated, and how it will see if the blockchain is valid or not. Okay, so this we are going to see, and then we will look at a demo of blockchain as well. So let me just start explaining the proof of work. So you see, we have seen that using Merkle root tree, we can have all the transactions in a chronological order. All right, that is, all the transactions in a block are chronological order, and we can see if we are able to justify any transaction or not. If someone tries to snoop in and make some changes, then we will able to understand it. We can see that there is some issues in the blockchain, but that was only for a single block. Now talking about the various blocks, how it is going to identify the issue in various blocks. Okay, so for that it uses proof of work system, that is POW system. Okay, so what happens in this proof of work? What happens in this proof of work is that we can see here, this is block 1, block 2 and block 3 of a blockchain. Every block has its hash, and I have already told you that how hash of a block is computed. I will just move towards the next slide for a second. So you see, this is how the hash of a block is constituted, like this. This we have discussed in the previous video. So this is how basically hash is constituted, and every block contains its own hash as well as the previous hash. That is, we can see here, this is the second block. So this second block contains one hash, that is this second block's hash, and also this first block hash. Alright, similarly this block contains its own hash and this hash of the previous block. So now let's say someone tries to make changes in this block. Okay, someone tries to make changes in this block, then what will happen? The hash of this block, that is this thing, is going to change, and that will change. So this previous hash will change, and this previous hash will change, then this hash will change, and all the other blocks will become invalid. All right, so this is how it is going to sense a blockchain, that is a block is validated or not. Now when we make any transaction, when illegal transaction happens or anything illegal or something happened, that is, which is not correct, then it will be beneficial for us, that is, we will be able to identify the theft. However, let's say we are making some transaction, that is, for example, this is A and this is B. It is actually sending some ether. So when some transaction is happening, the hash will change. All right, because these transactions will change. So then also it will show this thing is invalid, and to make it valid, that is to verify the transaction, there is this process, that is mining. Okay, we will see in detail about this process, what is mining, how it is done. So this is how a blockchain proof of work system works. Now first of all, we will see how a blockchain is formed. All right, although I have made it pretty clear, but we will see one by one. So this will make it easier to understand. All right, so here you can see it is the 0th block, and since it is there is no previous block, so it has this 0 hash address, and there is this block data. Now next thing is that another block is added. This is the block #1 block. Okay, so now what will happen is that this previous block, it has this previous 0 hash data because there is no previous block. This is the hash of this block. Okay, next thing is this hash is present in this previous block hash in the second block, and this block will be having its own hash. We will see in the next slide. We can see this block has its own hash. Similarly here, this hash is stored in this block like this, and this is the hash of this block. So this is how a blockchain is formed. You see, this is how the hash is created. I have already shown that. I guess this slide is repeated. Now let's see if someone tries to make changes in the form of Merkle root tree, that how it is actually happen. So we can see that in a Merkle root, all the transactions are stored in a block in chronological order. Okay, I will just use a different color pen. Yeah. So in the Merkle root, we have seen all the data is stored in chronological order, that is like this. So let's say we try to change something in T7 in this block. So in T7 it will change. Okay. So what is going to happen? All these transactions will change up till this root hash. So this hash is there in the Merkle root hash. This thing will change. Okay. So what will happen? We can see that this hash changed. This is something like this here. Previously that is 8b4, and here now it is changed to this something hash. So once this hash changes, what will happen? That this hash also changes. Okay, sorry. Yeah. What will happen is that this hash will change. Once this hash changes, this hash will change. Once this hash changes, this will change, which will change this hash, and again this will change, and whole blockchain will become invalid. We can see this changes, which makes this change, and finally this hash changes, and so on. So this is how we will know that there is some issue in this, there is some changes in this block. All right, so this is how blockchain actually changes, and from proof of work system we are able to identify that there is some snooping around. All right, so now we will say we will see a blockchain demo, so you will be able to understand. I will paste the link in the description, so don't worry. You can see this is a chain of blocks, that is, these are the blocks, and you can see that there are, every block is having the previous hash. That is, you can see here this hash, that is this one, this hash is present in this previous hash of this block is present in this previous hash. So these are, there are no transaction here. Now let's say I try to change data in here, so you can see all the blocks forward to this blocks becomes red. Okay, that is, there is some issue. So now in order to let's say, see, we are assuming here that these transactions are illegal, so that's why it is for benefit to us. But let's say there is some legal transaction, that is, someone sent some ethers, so that can happen, right? And this is a legitimate transaction. So for that, the process to verify that transaction is actually there and is verified, we use mining. So you can see here these mine buttons. So when I click on this mine button, mining will happen and it is going to mine, and you can see the hash changed. That is, the hash is changed according to the data. So you can see we can mine here. It will contain previous hash, and this hash is going to change. Okay. So you can see this hash changes. And one more thing I would like to show you, that you see, first of all, let's mine all this, and let's mine another as well. Yeah, so see, now all of these are validated. Now let's one thing I need to tell you, that if you have noticed while mining that when I changed the data, before changing the data, there was this kind of hash. All right, this kind of hash was there, but when I changed the data, some other hash appeared, and after mining, another hash appeared. So you can see here, when there is A written in this data, there is this hash. All right, when I add a B here, you can see there is something, another hash, and when I mine this block, that hash will be different. All right, you can see it is 0000 F8 something, and when I move it back towards the A, it is basically 0000193. All right, and when I add B, it is something totally different. So why there are three hashes? And that is actually the thing I would like to talk about. That first thing is, first hash is when you wrote an A, that is when a transaction happened. This is the valid hash. Now when there is some snooping or another transaction or something, before verification, there is this hash generated. That is a computational mathematical problem. That is the process of mining. In the mining process, what we need to do is we need to solve a computational mathematical problem. That is actually this is a target hash, that is this hash 9BC41. We are seeing this is a target hash, and mining will happen once our computer, our system is able to find out a hash that is less than this mining hash, this target hash. That is our challenge. And you see there are various types of miners set up in the internet also. There are various miners available, that is GPU miners, CPU based miners. These are available. That is, some are saying claiming that they are faster than others and so on. What that faster means is that they are basically calculating that hash, target hash, before the other miners, and the first one to do so gets the reward. So when you click on mine, your target is to calculate a hash address less than this. Okay, so you click on mine here, and you can see this hash address is definitely less than the previous one. Okay, so this is why I hope this hash concept is clear. Once I will just move towards next slide, and then it will become more clear. Okay, so you can see here, talking about mining. Yeah, just give me a second. It is a race to solve computationally hard problem very fast and become a winner. Okay, basically when in a blockchain network, if let's say you are a miner and you are mining the block or transactions in a blockchain, so what will happen, along with you there will be thousands of other miners as well, and those the one miner who calculated the hash value first will be rewarded. As you have seen in blockchain transactions, when we spend these ethers, actually there was some exact amount was something less than 99. Okay, and it because some fee was deducted as a mining fee. Okay, so that is the actually that is the fee, that is the reward that goes towards the miner. All right, so I will just show in the transactions. We can see here there is this gas price and gas use sum here. Okay, it is not showing the proper data anyways. So there is some transaction that happened, some reward that goes towards the miner. All right, you have seen that in this. I will show that in the Metamask. Just give me a second. The actual amount was sent and received was a bit less and more than that you transferred. That is because that fee goes towards the miner. So yeah, it is opening. Okay, so when we click on this transaction, we will see that there is total this much ethers was spent. That is, we spent 1 ether, but this much ether was spent because this amount, that is 0.00004987 ethers, was deducted at the as the mining fee. All right, so this is how this transactions happens, and a bit mining fee is deducted, which is given as a reward to the miner. So now talking about the computational hard problem, that is, there is this we are talking about the computational hard problem. Now what is this? So it can be understood in this way. That is okay, just a second. Yeah, so it can be understood in this way. That is, Bitcoin uses cash proof of work system as mining basis, and hard computational mathematical problem is like this. Given the data A, find a number x such that the hash of x appended to A is the result less than number B. All right. It is basically like that is there is the data and number x, that is it is appended, and it the hash of the x appended to A should be less than this target hash B. So basically it is kind of this hash cache system proof of work. We have seen in the demo that the final hash was always less than the target hash. So for example, this is an example from Geeks for Geeks. It is a very good example and we can see that it is showing with the hash to check for a value of bits and compare it to another hash. So basically it is going to take some of the first bits value for the exponent and mantissa, and then it is going to compare that, plug into the formula, that is this formula, to found this target hash. So now this target hash is found, and now it will see is the hash smaller or equal to the difficulty. So that is, if the hash is less than the target hash, then that means our hash is valid. All right. So this is how this hashing is done. That is, the proof of work is done. Now, some more thing about hash, that we are using hashing in everything. Like we use in SHA-256 and in this proof of work system, everything. So why we are using? Because hash functions are not invertible. That is, we can find the hash of y, but we cannot find x if y is given. Okay, so that's why hash functions are not invertible. For example, so here the question is, how do we find x if we have y? So we randomly choose this x and compute h of x until we find y. We can do that, but here why we are not doing so? Because it is so hard. That is, finding this x will take at least this much amount of tries to find y. Okay, so that's why currently we don't have computational resources. However, with the increase in the quantum computing technology, it is actually being made possible, and it is said that within upcoming 5 to 10 years we will be able to compute the hashes, because that will be able to solve larger mathematical problems like this in some minutes only, if we go into the quantum computing. Okay, however, currently we do not have such resources. So basically, if we are simplifying it more, how to find this thing, that if we need to find the hash, basically this is the probability that we get to find the correct hash, that is to actually find the correct hash. Now let's say we have seen in this demo, that is all the hashes changes. So we can see, a person can snoop in and even make these transactions legit by finding these hashes, if and only if he finds the correct hashes, that is from the data. That is, if he finds that after writing AB what will be the final hash there, then only he can snoop it. And for this, the probability is this much. That is very less, and it will take at least this much amount of tries to find this, and for that we don't have computational resources as of now. So this is how, and this is why blockchain is immutable, and this is how the proof of work system in a blockchain works. Okay, and that's why we say it is safe and secure and everything. So this was a small course or lecture series on blockchain. We have covered all the concepts. It is a theoretical one, because blockchain is kind of a thing that we need to understand the theory and the concept, because the beauty of blockchain lies within the theory and the concepts. Because previously I have added a series on Solidity, where we have used the Solidity programming language to write smart contracts. Okay, but that thing won't explain blockchain. Okay, that will give you an idea, an overview of writing smart contracts, and that's a good thing as well. But you won't be able to understand blockchain. People nowadays only know blockchain for their for the Bitcoin or cryptocurrencies as only. However, there is so much more than Bitcoins and cryptocurrency. There are a lot of things that blockchain have a lot of applications. You have heard about NFTs, and it can also have applications in the form of land contracts and everything. Anything in the form of a smart contract can be added into a blockchain. All right, so that's why it is important to understand how a blockchain is actually built, how it works. All these things, all these algorithms are being used, and the core of the blockchain is SHA-256. That is the hash function, hashing compression function, is the core of the blockchain, or that is the heart of the blockchain. The better the hashing compression function is, the better will be the blockchain. The better it will able to generate hash more effectively, the better will be the performance of a blockchain or a blockchain miner. Okay, so this was all about this series. This is all about the blockchain. I hope you are able to understand now how a blockchain actually works from the inside. Okay, so I know it can be overwhelming while watching the series in a single go. So I recommend you to watch it again and again, because it will take some time and some of your effort to understand what blockchain is. I will put all the links, all the help links and all the handbooks and demos and everything in the description. So what you can do is you can watch the video, you can open the handbook, and side by side with the video you can understand with the handbook what is actually going on. All right, so this is all for this video, and I hope you are able to understand about blockchain. So this is all for this video. See you guys in the next video.